Hello class, welcome back to this YouTube channel, and today we'll discuss the General Mathematics lesson 13, which is about representing real-life situations of exponential functions. So first, let's define what is this exponential function. So exponential function is a function of the form f of x equals to b raised to x or y is equals to b raised to x, where b is a positive number not equal to 1 and x is any real number with variables. So in exponential function, we have two components which are the base and the exponents. Your base, denoted as letter b, should be greater than to 0. That means it should be only a positive number, and your b should not be equals to 1. And your exponent, which is denoted as x here, is any real number with variables. So x here is a variable. Now let's define what kind of applications wherein we can represent the exponential function. So first, common applications, we have the exponential growth by doubling. So how this doubling happens? So if a quantity y doubles every t units of time and y sub 0 is the initial amount, then quantity y after t units of time is given by y is equals to y sub 0 times 2 raised to t over capital T. So in exponential growth by doubling, we have an assumption amount, or for example a population here, which is denoted as y sub 0 as initial amount, and to know the quantity every time that the unit t doubles. So this is the function on how to compute the future growth or population. So our small t here is the time to double time that you need to compute the quantity, and the capital T here is the time when the population doubles. So let's have an example.
So we have here an example problem in exponential growth by doubling. At t is equals to 0, meaning initial time, there were initially 40 bacteria. Suppose that the bacteria doubles every 200 hours. Give an exponential model for the bacteria as function of t. So let's try to solve this particular application. So we have a given bacteria for the solution. So let's write first the given. So our initial population of the bacteria, we have 40. And then every 200 hours it doubles. So the capital T is, our capital T is 200 hours. So what is the problem? So we need to give the exponential model for the bacteria as a function of t. So let's say, for example, as given in this problem, initially at t is equals to 0, we have y, which is the number of bacteria, that is 40. So at 200 hours, we have y is equals to 40 times 2, because it says here that your bacteria will doubles. That means you should multiply it by 2. when your time is 200 hours. So what about if the time doubles also? So we have 200 times 2, that is 400 hours. How many bacteria do we have? So we have y is equals to 40. So your bacteria again will double. So it will double twice because you have 200 divide 400 divide 200, so that is 2. So it will double twice. Let's try if your T is equals to 600 hours. How many bacteria we have? So we have 40 times 2. So since 600 divided by 200, that is 3 times. So your bacteria will double 3 times. So we have times 2, times 2, and times 2. So if we're going to simplify this, so initially, this is just y sub 0. So this one is your y sub 0 times 2. Then you have the t, which is 200 divide 200. So that is just 1. This time, so we have y sub 0 times 2 raised to 2. So because we have twice, you have 2 times 2. Then this one, we have y sub 0, which that is the 40. Then 2 times, how many 2's we have? So raised to 3. So now, the exponential model of the bacteria, which is a function of t, so that will be y of t equals to, what is this, 40? That is y sub 0 times 2, meaning your bacteria doubles. So now we have t, so the given t divided by 200. So this 200, your capital T. So we need to divide first your time to 200 because that is your unit where your time when the bacteria doubles. So our y of t, our function, is 40 times 2 raised to t over 200. So this is our exponential function.